Scene script. Have you ever gazed at the night sky and wondered how vast the universe might be? Let's embark on a cosmic journey to explore the incredible vastness of our universe. Picture the universe as an endless expanse of space, a limitless canvas painted with countless galaxies, stars, and celestial bodies. It's a realm so vast that it's almost impossible for our human minds to fully comprehend. Now, imagine just how many galaxies are scattered across this unfathomable expanse. Astronomers estimate there could be about 2 trillion galaxies out there, each one teeming with billions of stars. That's an astronomical number, so large that it's hard to wrap our minds around it. But what's even more intriguing is that our universe isn't static. It's not sitting still like a painting hanging on a wall. Instead, it's dynamic, constantly shifting and changing. And one of the most fascinating aspects of this is that the universe is expanding. Yes, you heard that right. The universe is getting bigger all the time. This isn't a recent discovery, but something astronomers have known for nearly a century. The idea was first proposed by Belgian physicist Georges Lemaitre in the late 1920s, and later confirmed by Edwin Hubble's observations. The galaxies are not stationary, but are moving away from us and from each other. This is due to the expansion of space itself. It's like they're on the surface of an inflating balloon, spreading apart as the balloon expands. However, it's important to understand that it's not the galaxies themselves that are moving. Rather, it's the space between the galaxies that's expanding. As space expands, it carries galaxies along for the ride. It's a mind-boggling concept, but it's one of the fundamental aspects of our understanding of the cosmos. So the universe is constantly stretching, but what exactly does that mean? Well, that's a question we'll delve into as we continue our journey through the cosmos in the next segment. So buckle up, space travelers. The ride is about to get even more fascinating. Scene script. An expanding universe might sound like a complex idea, but it's not as complicated as you might think. Imagine a balloon. When it's uninflated, the surface is all crinkled and close together. But as you inflate it, the balloon's surface stretches out and expands. Now, if you were to draw tiny dots all over the balloon before inflating it, you'd notice something interesting as you blow it up. The dots, which represent galaxies, start to move away from each other. This is essentially what's happening with our universe. The universe isn't a static entity. It's dynamic, constantly in motion. It's not that the galaxies themselves are moving through space, rather, space itself is expanding. So, galaxies are carried along for the ride, just like those dots on the balloon. Now, you may be wondering, if all galaxies are moving away from each other, does that mean there's a center point from which everything is moving away? The answer is no. The center of the universe is a concept that doesn't really apply in this context. Think back to our balloon analogy. If you're a dot on the balloon surface, you see all the other dots moving away from you. But every other dot sees the same thing from their perspective. There's no single center on the balloon surface. Similarly, every galaxy in the universe sees all other galaxies moving away from it. In the grand cosmic scheme, the universe has been expanding since the Big Bang, some 13.8 billion years ago. This expansion is not slowing down. In fact, observations suggest it's accelerating. But what's causing this acceleration? What's the driving force behind this expansion? Those are questions that delve into the very fabric of our universe, into the mysterious and unseen aspects of our cosmos. It's a journey that takes us from the visible and known to the invisible and unknown. Now that we understand the universe is expanding, let's delve deeper into why this is happening. Ever heard of dark matter? It's a mysterious and invisible substance that's incredibly important to our universe. Now you might be wondering, how can something we can't see or detect play such an enormous role? Well, it's a bit like the wind. We can't see it, but we can observe its effects, like the rustling of leaves or the fluttering of a flag. Similarly, dark matter, though unseen, exerts a gravitational pull on galaxies, influencing their formation and movement. Imagine the universe as a cosmic ballet, with galaxies as the dancers. These galaxies don't move randomly. Their movements are choreographed by the gravitational forces acting upon them. And one of the key players in this cosmic choreography, you guessed it, dark matter. Despite making up about 85% of the universe's matter, dark matter doesn't interact with light or any form of electromagnetic radiation. This means it doesn't absorb, reflect, or emit light, making it extremely difficult to detect. Yet, its presence is inferred from its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. In terms of the universe's expansion, dark matter plays a crucial role. You see, the gravity of dark matter works against the expansion of the universe, slowing it down. But don't be mistaken. Dark matter isn't trying to halt the expansion. Instead, it's more like it's gently applying the brakes, keeping things in check. Another interesting aspect of dark matter is that it serves as the cosmic glue that holds galaxies together. Without it, galaxies would fly apart as they rotate. So, in a sense, dark matter is the invisible scaffold upon which the visible universe is built. To sum up, dark matter, while elusive and mysterious, is fundamental to the structure and evolution of the universe. It's the unseen puppeteer orchestrating the dance of galaxies and influencing the universe's expansion. It's fascinating to think about the unseen forces shaping our universe, isn't it? Now imagine a tapestry, but instead of threads and colors, it's woven with galaxies. Our universe is not a random scattering of galaxies. Rather, it's an intricate network, a cosmic tapestry woven with galaxies. This vast network is not just a beautiful sight to behold, but also an essential piece in the puzzle of our universe's structure and evolution. Galaxies, like the threads of a tapestry, are not scattered randomly. They are organized into groups and clusters bound together by the gravitational pull. These clusters of galaxies are the building blocks of the larger structure of the universe. But the story doesn't end here. These clusters themselves are interconnected, forming even larger structures known as superclusters. Superclusters are the largest known structures in the universe, and they make up the fabric of the cosmic web. Yet, within this cosmic web, there are also vast voids, spaces devoid of any galaxies. These voids and the cosmic web together create a pattern, a cosmic tapestry woven by the galaxies. As we delve deeper into the cosmic tapestry, it becomes evident that it's not a flat two-dimensional weave. It's a three-dimensional construct, reflecting the depth and complexity of the universe. Each galaxy, each cluster and supercluster, each void is a testament to the grandeur of the cosmos. It's fascinating to think about how this cosmic tapestry came into being. It's the result of billions of years of cosmic evolution, shaped by the interplay of matter, energy, and gravity. This tapestry is continually evolving, with galaxies moving, interacting, and sometimes even colliding. And yet, amidst this dynamism, the tapestry maintains its intricate pattern. It's a testament to the delicate balance that governs the universe. From the smallest galaxy to the largest supercluster, everything has its place in this cosmic arrangement. And so, as we step back and admire this cosmic tapestry, we are not just looking at a beautiful sight. We are witnessing the grand design of the universe, the intricate pattern woven by the galaxies, clusters, and superclusters. The intricate pattern of galaxies provides a beautiful and complex backdrop to our expanding universe. We've journeyed through galaxies and dark matter, exploring our ever-expanding universe. But what does all this mean for us? The notion of an expanding universe is a fascinating concept, one that challenges our understanding of our place in the cosmos. As we delve deeper into the mysteries of the universe, we find ourselves standing on the brink of a vast cosmic ocean, its waves carrying galaxies farther apart, its depth filled with enigmatic dark matter. This expansion isn't just about the universe growing in size, it's about space itself, stretching and creating more room for galaxies to move away from each other. It's about the realization that the cosmos is a dynamic, ever-evolving entity, not a static backdrop against which the drama of life unfolds. The knowledge of an expanding universe compels us to reflect on our existence. We're not just inhabitants of a planet, but participants in a cosmic dance that spans billions of years. We're part of a universe that's far larger and more complex than our ancestors could have ever imagined. Yet, amidst this grandeur and complexity, we find a sense of unity. The same physical laws that govern the motion of galaxies also dictate the orbits of planets and the fall of an apple to the ground. We're all woven into the same cosmic tapestry, bound by the same threads of matter and energy. This perspective can be humbling, reminding us of our tiny place in the grand scheme of things. But it can also be empowering. By understanding the universe, we're part of something larger than ourselves. We're not just observers, but active participants in the cosmic story. As we continue to explore the universe, each discovery is a new verse added to this grand cosmic narrative. And with each verse, we gain a little more insight, a little more understanding, and a little more appreciation for the cosmic dance that we're all a part of. As we gaze at the night sky, we're not just looking at stars and galaxies, but witnessing the grand story of the universe unfold before our eyes.